Hey everybody, it's Miss Schmeg with lesson 3.5, Parallel Lines and Triangles. Your learning targets for today are I can classify triangles and find the measures of their angles, and I can use exterior angles of triangles. So the first thing that we're going to talk about today is triangle angle sum theorem. So what that means is all of the angles in a triangle add up to 180 degrees. So angle A plus angle B plus angle C is all going to add up to 180, always and forever. It doesn't matter what type of triangle, it's always going to be that way. So when we are looking at this next proof here, it says that we are given triangle ABC. So they have that filled in for you there. And it wants us to prove measure of angle A plus the measure of angle E plus measure of angle B plus the measure of angle 3 equal 180. Okay, so that means we're looking at these three angles here. Okay, so we're going to use our angle relationships to prove that those three angles are going to all add up to 180 degrees. So we are going to say that CP is parallel to AB. Okay, so CP is that line above on top, and then AB is this line in the bottom of the triangle. They are going to be parallel, and the reasoning for that is going to be converse of alternate interior angles. And then we're going to say that angle 2 is congruent to angle B. Okay, so angle 2 is congruent to angle B, and those ones are going to be alternate interior angles. Now we can say that angle 2 equals the measure of angle B, and the measure of angle 1 is equal to the measure of angle A. And that's going to be definition of congruence. So remember, when we're changing from an equal sign and a congruent sign one way or the other, so we have congruent to equals and congruent to equals, that's going to be definition of congruence. Okay, so then now what you can say is you can say that 1 plus 2 plus 3 are all going to add up to be 180, and that's going to be angle addition. Okay, so those three angles all go together to form a straight line. Okay, so this straight line right here. So that all has to add up to 180. And then what we can do is we can use some substitution to fill in angle 1 and angle 2 as angle A and angle B. And that's going to be the end of it. So now we have exterior angles and we have remote interior angles. So an exterior angle is an angle formed by a side and an extension of an adjacent side. So that's going to be this letter X out here. Then we have remote interior angles, which means the two interior angles that are not adjacent to the exterior angle. So they're going to be across the triangle from where the exterior angle is going to be located. So then our next theorem is going to be triangle exterior angle theorem. And what this says is that the measure of each exterior angle is equal to the sum of its two remote interior angles. So if you look at the diagram above, what that's going to mean is you're going to say angle Y plus angle Z is going to be equal to angle X. Okay, so moving on then to the next page, we're going to use that theorem. So when we are looking at these angles, these two angles in red are going to be your remote interior angles, and then this angle in green is going to be your exterior angle that you are trying to find. Okay, so we're going to add our two remote interior angles together, and that's going to be equal to the exterior angle. When you go to do that, you're going to end up with X is equal to 125 degrees. Okay, we're going to do the same thing over here. We're just going to do 75 plus 68 is equal to N. So then N is going to be 148 degrees. Now this next example here could be a little bit more tricky. So what we're going to do is we're going to recognize the fact that all of the angles in a triangle have to add up to 180 degrees. So if I am looking at just this triangle here, okay, so just this right triangle. Okay, when I look at that triangle, I know everything inside of there, all three angles have to add up to be 180 degrees. So I can do 55 plus 90 plus x to figure out what x would need to be in order for them to all equal 180. So when I do that, I'm going to get x is equal to 35. Now, x and y are going to be a linear pair, so those two need to add up to be 180. So I can figure out what y is by doing 180 minus 35, which will get me 145. Which then means our last one here, I have 10 plus 145 plus z equals 180, and z is going to end up to be 25 degrees. Now on this one here, we're going to kind of go the opposite direction of the theorem of exterior angles here. So we know that these two angles, because they form a straight line, they have to add up to be 180 degrees. So that means that this angle inside is going to be 60 degrees. Okay, so then I can do 32 plus 60 plus angle 2 to figure out what angle 2 is. When I do that, I should get a measurement of angle 2 is 88 degrees. And then over here, we're going to do the same thing that we did on example number 3. So we're going to look at this triangle here first. So all three angles in this triangle have to add up to be 180. So that means that the measure of angle 2 is going to be 52 degrees, because 52 plus 38 plus 90 is going to get us 180. Okay, now these two have to add up to be 90 degrees. Or another way that you can look at it is if I have 31 here and 116, angle 1 needs to be what's left of 180. Okay, so when I do that, I'm going to end up with angle 1 is 33 degrees. If I do 31 plus 116 plus angle 1 is equal to 180. Okay, so angle 1 is 33 and angle 2 is 52. So last problem for today, we want to find the unknown measures of the angles if the ratio of the acute angles in a right triangle is 1 to 2. Okay, so I changed that 1 to 2 to x and 2x. Okay, just to make it a little easier because we're used to dealing with variables here. So when I do that, I know that these three angles in this triangle have to add up to be 180. So what I can do is I can do x plus 2x plus 90 is equal to 180. And when I do that, I'm going to have 3x plus 90 equals 180. Which means 3x is going to equal to 90, which means x is going to be 30 degrees. So then when I'm trying to fill in for what these missing measures are, I'm just going to plug 30 in for x. And when I do that, that means this is going to be 30 degrees. And that means this is going to be 60 degrees. So it's going to be a 30, 60, 90 triangle.